Hi, I'm with Savvas Kleanthous today. Savvas is head of engineering of partial vision, which is in logistics, but I'm going to let you explain that. You do that better than me.
Thank you, Yves. Hi, everyone. My name is Savvas Kleanthous. I'm the head of engineering for Parcel Vision. In Parcel Vision, we develop software for major fulfillment houses and major retailers to deal with price optimization for the shipments and also handle after-sale requests. We use event sourcing heavily in our solutions, and necessarily this is a distributed system with multiple components with multiple responsibilities. And part of that is going to be in our the discussion today. So the feedback loops that we were going to be discussing, right?
Yeah. Because when the reason I want this is because of those feedback loops and the fact that you have a distributed system, you have a distributed team as well, and so you told me that you have feedback loops everywhere, and that one of your main goals is to increase autonomy of the teams and in the system itself. So,
yeah. So when I joined Parcel Vision, I joined this as a kind of an R&D. When we started, at least, it was kind of an R&D project about what we could do to address some of the after-sales problems that exist. So after-sales is particularly important and interesting as well because in the logistics industry, most of the effort involved is pre-sales and cost calculation. Very little happens after the after sales has happened. A lot of carriers will quote, okay, they will give you some complicated structure so that you can calculate how much it will cost you. They have a set of rules with regards to how things will cost, and and there are a lot of rules in different countries regarding customs and so on, but there is very little information or tools to help you with regards to after sales. So when a shipment is shipped, what can happen to it, and how do you actually fix any kinds of problems? So we started with that, with an investigation about what we could do to address that problem, which was a problem that the company already was facing themselves. And at the same time, we had to deal with the other part of the business, which was the price optimization, of course. So in order to fix that problem and address that problem, we had different components in the system, and obviously different teams working on the different components. It was quite interesting to discover that there weren't a lot of, as I mentioned, there weren't enough documentation. There wasn't enough documentation about how to detect and how to fix a lot of these problems. And during that phase, what we came up with was basically recognize that we needed to be reactive in a lot of the situations. And at the same time, because there wasn't the documentation, we couldn't be just reactive in the sense of, if this particular problem happens, then you need to do this, you take this kind of action. We needed to be reactive and also be able to detect when things were abnormal, when they were outside what we already recognized at certain situations. So, and it's also quite interesting of a discussion how that couples with domain-driven design, because this being not documented meant that at the same time we didn't have a lot of domain expertise, and neither in-house about the particular problems that existed, but also in general in the industry. So a lot of the carriers themselves, they don't maintain a list of issues or exceptions a shipment may go in. So we created a system that was able to detect those abnormalities and then raise them to particular people, and those particular people will take a particular workflow that was outside of software in a lot of cases, and then that will result in either changes in the system itself or changes in the configuration of the system so that it could react and takes the relevant actions. So feedback loops were really, really important in order for us to do that. So that's basically how we address the problem.
Yeah, and how do you decide if this is something that will still be manual handling by someone, or just to integrate it in the system and let the system evolve to take care semi-automatically, probably in the system itself?
That's quite a long discussion, I will say, in and of itself, how we decided. But
next discussion.
Next discussion, yeah. So it's a combination of things, as I said. But in general, what we do is we allow the business analysts, well, we have a team of business analysts that are taking the history of changes that occurred in the system. And this is quite interesting, in fact, because in and of itself is very related to event sourcing. So if you see the carriers, what will give you, they will give you a status, like they will tell you this shipment is in this kind of status. But very often that, especially when we're talking about exceptions, that is not that accurate. So they may tell you, for example, that there is a generic error in your shipment, but in fact, when you actually go in and read the scans, you will understand that it's one particular problem. Some carriers will tell you that there is a problem with customs. You need to call customs, but in fact, the information that we expose in scans actually point to one particular type of problem. So it's what I said earlier, that they don't actually know the precise details about the errors that the shipment are in. So when I'm saying that, the way that we are dealing with this thing is that one of the mechanisms that we deal with this thing is we expose all of that history of the changes that we have detected out to the business analyst when we're not able to decide ourselves in an automated manner. And so that takes the feedback loop of going through certain people, analyzing things, and then this could result in a reconfiguration of the system or of this accordingly to a change in how the system behaves in and of itself.
Yep.
Sometimes we have recognized that certain types of problems make more sense to be manually handled. So there are situations and problems that we detect that we basically redirect the users to take certain manual actions to address them. So these are stuff that we have already analyzed before, and we recognize that we recognize the situation. We also recognize that there isn't any automated action that we can take to resolve this, and so it needs to take some manual route to get addressed. It's quite interesting how we came up with that solution again in the DDD context, which I mentioned in the beginning, because in domain-driven design, language is very often quite important, and the actual domain itself is written using strict domain rules. And what the solution we came up with is that those rules are actually driven by configuration. So we have created, in essence, it's basically a change in understanding of what our domain is in that bounded context. So it changes, and it's not that particular bounded context is no longer a shipment status resolution bounded context. Let's say it's more about a bounded context to expose a rules engine that can be configured by experts and reconfigured as well by expert, and have those rules versioned so that it can detect the correct status for a shipment.
Yeah, and I guess if you have that kind of change in one boundary of the system, that evolves continuously, how do you make sure that the rest of the system is not too impacted by it? Because there might be some changes there. So talking about distributed system where we have integration between autonomous part of the system, or disconnected part, not disconnected, but part that need to somehow talk to each other.
Yeah, correct. Now that's a very interesting question, in fact, and the way that we have dealt this is recognized and through event storming in this particular case, the parts of the system that can change, and the parts of the system that change frequently, and the parts of the system that don't change. So in our particular situation, we have some bounded contexts that are stable and some bounded contexts that are not that stable. The bounded contexts that are stable are the ones that carry the semantics of the shipment status. Shipments have been, so the status is basically are recognized themselves. So we know, for example, that a shipment can be in transit, a shipment can be in exception. We recognize that a shipment can be stuck in customs, a shipment can be stuck because it cannot be delivered because the address is wrong. There are different reasons why a shipment can fail, and those are pretty much recognized. The things that tend to change is how that is communicated, and of course the actual particular types of problems may change from carrier to carrier in some cases, but the actual problems are pretty stable. So the generic, let's say the categories of problems that we have are pretty stable, and those generally tend to have a one-to-one relationship with certain actions that can resolve them. So splitting those two, the understanding of the situation and what you do about the situation, actually helped us a lot, and that's the kind of boundaries that we have, and we decided to integrate according to the situation. So when we are so the way that we communicate the scans and the way that those change and deduce information is one bounded context, and then the understanding of that situation, so that the shipment can change status, as in a status from the point of view of a state machine, for example. That's a separate bounded context, and then downstream bounded contexts can address that.
And when we talked about this in a private call, you told me something about that you found it interesting that the owner of the semantics was the most stable and the most stable context, so shipment in this case, I guess, and that the one changing, so the resolution, I just forgot the term you use, but the resolution one must comply to that contract, which is a strange dependency, because you would expect shipment to use the resolution instead of resolution being
Yeah,
the dependency, the process dependency is towards, if I understand correctly, towards the resolution, but the semantic dependency is from the resolution to the shipment context.
that's very correct. This is, so basically these are the lessons that I used. So this is the experience that that caused me to come up with a decision tree, basically, that I use very regularly in order to decide what is the what's the best means of integration between some services. So just to provide a little bit more context and to be more precise, so in our situation we have a bounded context that retrieves the scans from the carrier. This can be thought of as a supportive bounded context. It's an integration basically to the carriers. So it reaches out to the carrier, it receives the set of scans, and it does some very rudimentary processing, basically parsing and matching it to something that we understand locally, because it's just text and numbers, and then in each carrier uses difference. So we just normalize, let's say, those particular scans into something that we understand. And then there is a bounded context that interprets them. So we take the history of scans and we come up with we call them status elements, because it's just little pieces of hints to a status, all of them combined to make a status. What humans will understand, this is the situation that the shipment is in at a particular point in time. And then in response to that, we understand, we call it a progress. So it's a lot of terminology, but we interpret it as a higher level thing that we can say. So this shipment is in exception, this shipment is in transit, this shipment is out for delivery, and then accordingly we have a bounded context that tries to resolve, either automatically or by asking some people to take some actions, the exceptions that the shipment is in. So you're very right in saying that process-wise, there is a unidirectional flow of information. So the pulling scans needs to inform the status calculation, which needs to inform the shipment, so that the shipment can interpret them and update its progress, which we can then inform any downstream consumers to kick off certain reconciliating actions and so on. However, that first bounded context, that second bounded context of interpreting these scans that we receive into the status that we have, that's very, very dynamic. And it went through a lot of iterations, as well as we tried to integrate with more carriers and try to interpret the status that we got, and especially throughout history, because as I said, the carriers themselves change what they say from time to time. So in some cases they will say the shipment is in transit, in other cases they will say that the shipment is en route to your destination. I mean, that's a very simplistic example that is not very complicated, but there are situations, especially around exceptions, where the way they convey this information is much more complicated. And there are always some information that we want to extract out. So sometimes they will tell you that there is a problem with your delivery depot. So we know that it's very close to the destination, but that we need to do something particular to that destination. It is particularly important, versus there is some problem elsewhere that you have some time to fix it, for example. So recognizing those dependencies, recognizing the volatility of those different bounded contexts actually helped us, because given the rates of change that we had in that status calculation bounded context, allows us to, we recognize that coupling to that meant that any service that was coupled to that will have to also change and update whenever we change that contract. So whenever we discovered that those events need to evolve and those events need to change, then any downstream consumer will also have to change to interpret them. And we didn't want to maintain two different versions. And obviously we have, that's another discussion about deployments and releasing and everything, which is pretty known, in fact. So we tried to address that by changing and flipping the dependency. So who depends on what? So in the situation of the more volatile depending on the more stable, in the one case where we have the status calculation is the more volatile. So it then creates with the shipment through commands. So we're pushing a stable command forward. But in the situation of, for example, of the detecting the kind of exception and what we need to address, that is basically an exception, an event. So we're having the dependency reversed, which means that the more stable bounded context the more volatile bounded context depends on the more stable one.
Yep.
Yeah.
That's a good one. And I guess that's the dependency in the system, but there is a system building the system, that's your teams, and they're probably organized in a way that one team is more dedicated to one part of the system, let's say the status calculation, one is more dedicated to integrating with carriers, the shipment part and so on. How do they exchange that kind of information? Because I know they are distributed over the world also. It's not only your base in the UK, but I know you have teams a bit everywhere as well.
Yes, that is true. Well, that's another kind of discussion. So we're moving a little bit away from that decision tree and going to we're a couple of things basically. So I think one of the more important things that we started to adopt in our teams is from team topologies and recognizing the different teams and the different statuses that we can be during development. One of the things that we have adopted and it's working quite nicely so far, at least, is recognizing when there is this kind of when two teams need to come up and decide with regards to a contract. We basically recognize that volatility, and then we what we do at least is team people up from the different teams. So one person from team A will join from one person from team B and form a temporary partnership to establish that particular contract that needs to be established. And then as soon as that effort is stopped, then the people can disseminate the knowledge that that was acquired into the relevant teams. So that's one of the ways that we use, and it's as I said, it's working quite nicely for us.
Yeah.
And the other way that we also achieve this, which is actually coming earlier than that, is we very regularly use event storming to analyze our domain and update our understanding of the behavior of our system and what our system is and the model in essence. And so based off that and the lessons that we discover from that, then we basically follow.
Yep. And you create your decision trees about how to integrate stuff. So those decision trees, they are available. I know you published them on Twitter some times ago. They are findable. I'll try to get a link for the video. But what's the main reason you decided to create those decision trees? And can you shortly explain what they contain?
Yeah. So for the decision trees, I needed to. The decision trees, I use them, and it may sound a little bit strange, but I use them so that I can enhance the autonomy of my teams. Sorry. So it sounds a little bit counterintuitive because decision trees basically have like a structure of when these do that and then when these do that. But it's the way that I use them that basically enable the team autonomy. It relates to also how do you give advice and reasonable defaults. So in a system, you want to have basically what's it called? Conceptual integrity. Sorry, I was looking for the term conceptual integrity. So a system should have conceptual integrity for multiple reasons. So the way to achieve conceptual integrity very often is to establish certain patterns in the system. But also it's quite difficult because those patterns don't universally apply. And they make useful, reasonable defaults, but at the same time, they can restrict the team into implementing something that is not applicable for a particular problem. And that's why usually with patterns, we very necessarily need to provide context. So this is the pattern, you use it in these particular cases. What I found is that you could use decision trees for something similar, and they are quite powerful to do that, as long as you are not enforcing people to use those even then. So you still provide that context. But the important here is that you don't provide just one. So it's not a pattern and you say, this is the pattern, use it. And this is the pattern, like use it or something like that. This is a decision tree where people are able to follow, to discover the applicable pattern at a particular after a particular set of answers. So it's a more granular, more detailed context into the applicable pattern that you need to come. And also the other important, as I said, is that these are not mandated. So as long as my team, basically what we do, as long as the team can explain that why they decided to go against the decision that they reached in that decision tree, then it's actually fine, and we follow with that. It's quite important because in a lot of cases, you end up in a situation where, I, as the author of that decision tree, could not think of it. And it's quite telling of the fact that this already changed 3 or 4 times, that decision tree, that particular integration method decision tree. And these are the discoveries that you go through. As long as people can explain why they're diverging, that is something that we need to accept. But as long as that happens, that is quite a useful tool to empower your team to make their own decisions. It's a useful default, reasonable default that they can follow in certain situations and help them make a decision. But it's also useful to assess the decisions that they are making when something is discussed on when we're in a modeling session, for example.
Yeah, it's a nice one. I had a discussion a few days ago with Chris Condron, our chief architect, and we were discussing coordination between services and or between streams and stuff like that. And the default, for instance, it's kind of the same example. There is the default. For instance, in event sourcing, we say, okay, if you have some kind of handler for an operation, you try to have one stream that is impacted by it. But sometimes there is a good reason to have multiple streams. But that's not the default. That would be one of 100 cases, and that's really important to recognize that yes, the pattern has an applicability domain.
Yes.
And
Yeah.
when you fall outside, you need to look for someone else, someone else, for something else, for something else. But that has to do with learning, and again, probably feedback loops and learning is that thing. Okay, what is the applicability domain of that specific solution, that specific model, that specific problem you're facing, and okay, what falls outside, what can be done inside, and if it doesn't fit, it doesn't fit. And I see a lot of problems, people struggling with that, recognizing this is just recommendation, but it stays a recommendation. You are allowed to go outside of that, but you have to have reasons.
Yes.
That's something I think we need as an industry to work on that.
Definitely. Yeah, I mean, it depends on the team. It depends on the safety that people feel. So it's quite important to develop that feeling of safety and the ability to, for people in a team to object somebody else. Object. Maybe object is a little bit strong of a word, but being able to safely express opinions and disagreements. Yeah. So that's quite important, and especially with people thought to be higher up in the ladder, so to speak. It's quite important that that safety exists. It's quite important for people to be able to express those opinions and be able to assess them accordingly. Without that safety, it's very difficult to happen. And I've seen a lot of companies where there is this kind of strict hierarchy where it's impossible. So a lot of the reason why this is not happening and then maybe it's not developed is definitely that, I would say, I mean, at least from my opinion. Yeah. And I've seen it and I've experienced it from well, that side of the fence in previous positions.
Yeah, we've all been there. That's a bit of off the topic, but I wanted to say that because I find it remarkable in previous discussion we had as well that you're trying to that the same pattern, I'm going to say the word, okay, you have autonomous boundaries, autonomous teams, and all those feedback loops that feed themselves and allow the system to get better. So that's extraordinary. Oh, I have an idea for the next conversation I'm going to have with everyone. Any book recommendations?
Any book recommendations? Well, yes. One of the books that I very highly recommend is the Toyota Principles from Jeffrey Liker. That's definitely one of the books that changed my way of thinking with regards to leading a team and developing a product. It's a really interesting book, and one of the more important aspects that it has, I think, it's quite interesting how it informed, I think, the development process, the development of software as well through the means of agile. So it seems that, and I'm almost certain of this, that the agile principles have been heavily informed from the Toyota principles that pre-existed. I mean, I'm not that certain about this, to be honest, but it certainly seems to be the case. A lot of the agile principles map quite nicely and to those. Yeah, you were going to say?
Yeah, I said there's a lot of coincidence in there, and
too much of a coincidence. Yeah,
that points to being quite heavily inspired by it, because there's some also temporal coincidence about the principles and the way they worked and where those people worked. So we'll probably never know, or we should try to ask them. But yeah,
Maybe.
the Toyota way, and yeah, so it did inspire some of the stuff you've or the way you work and the way your team are organized. Another one that you think people should absolutely read?
Well, yes. Well, I mean, if I should recommend 3 books, so at least for people in either in tech leadership positions or leadership positions in general, one is definitely the Toyota principles that we mentioned. Another one is team topologies. So team topologies is quite important from the point of view of coming up with a structure in your company so that you enable team for fast flow. And it's quite an eye-opening book, and a few important people actually recommended the team topologies book quite heavily in the past year or so, which was kind of how I came to read it, but certainly a very highly recommended book from me as well. And I think the third book that changed the way I worked, so as a software developer at the time, and then later on with me, my added responsibilities is obviously the Blue Book by Eric Evans. So,
Domain-driven design.
Domain-driven design book, yes. That's a very, very important book. I think it shows its age today. So a lot of the stuff in there definitely can benefit from a rewrite, I guess, or maybe an update or something. But it's still a very, very important book, and definitely worth the effort to be read. I cannot recommend it highly enough, basically. Yeah. I think the only thing basically that I think it's missing would be the concept of domain events. I'm pretty sure it's not in the Blue Book.
No, we mentioned it in other small updates in smaller books. They're mentioned there.
Yes, yes, indeed.
But I mean, the first part of that book is what it was and was quite good for the time it was out. The second part is in temporal, meaning if people want to read that book, read the second part at least.
Yes,
that's where all the good things about changed my point of view as well. Yeah, those are really 3 good books. So I think we're about the time we had dedicated for this. Thanks, Savvas, for your time and explanation. Let's conclude that, yeah, people should try to look for feedback loops, improve, and have some way of making everybody or teams at least as autonomous with good guidance. And we need to record another one of those days about the long discussion about integration. And I forgot this one. I will look at it again. Don't worry. Okay.
Well, we had.
No, you wanted to say something. Sorry.
I was going to say that
this is life.
The other, yeah, I guess. Well, the other discussion was about using the event sourcing events for integration.
Yep.
Which was, yeah, I think, well, I should have mentioned it when I was discussing about the pointing the what did you depend on. So, yeah, I should have mentioned it then. Apologies for that, but so I think it's a lot of stuff that are very related together that make up a cohesive whole that makes sense as they like together, basically. and it's difficult to like remember everything at once. But yeah, it's quite what was useful for us and what we what I like to do is, yeah. So basically, one of the advice that you can find when you are adopting event sourcing specifically is to avoid using the events that you use in event sourcing for integration. Very often, you will see a pattern where you will drive a small piece of logic using those event sourcing events. That will collect the data from the event, will fetch other data from inside the bounded context that it sits, and then publish an external event, something like an integration event that is higher level, encompassing different information, and is supposed to be more stable than the event sourced events that we use for storage. The reasoning behind this is that the event sourcing events are meant to be, as I said, storage. So it's exposing those is thought to be the same as integrating through, like sharing your database, for example, your schema, like directly, like giving access to some other service directly. The situation is a little bit more nuanced, in my opinion, than that, because event sourcing events, when done correctly, represent domain events. So these are events that are recognized by our domain experts. So somebody in the business that's not a software developer can actually understand what you're talking about when you say that the shipment went into exception, for example. That is, I can speak with everyone in the business actually and tell them that the shipment went into exception. All of them will understand what I mean. And it's quite often that when that exists, or when we have this kind of understanding of those domain events, that we can actually use them for integration purposes. And the reason that we can use them for integration purposes is because those are like, as the minute that they are known, it represents a domain that we are comfortable with, a domain that is quite possibly mature enough so that people know to interpret those events, and it's also stable because of that. So when we are developing it, we can reach out to those people that know this, know the interpretation, and they are quite probably going to be a lot in the business if that's the case. And that's it. It is going to be stable. Some of the behavior around how do we interpret, so how do we come up, with those events, some of the logic of data calculation, for example, may change, but the interpretation of the events do not change. And that stability and ubiquitousness as well, because I mean, another key thing is that I said earlier, I can tell that event and multiple people in the business will recognize it, implies that it can actually be used for integration purposes. So we have a bounded context that stores these types of events in the stream. They form part of that aggregate's persistence, but at the same time, they are used for integration purposes. They are very stable. The bounded context is stable. Their interpretation is known. It's a language that multiple people know, which means that multiple bounded contexts have that kind of have that term inside of their dictionary. So it is an event that is safe to be shared across.
Yeah. And that's totally in line with what you said earlier about the stable part owns the contract.
Yes, correct.
Yeah. And of course, if you own the contract, there's a few things you need to ensure to make sure that it evolves in a certain way and so on. So, but owned by the stable, so that's totally in line with what you said earlier.
Yeah, I mean, it's the stable. There are different levels of stableness, of course. So, I mean, some bounded contexts will be stable, as in certain terms will never change. So we don't expect the in-transit status to ever change its meaning. It will always mean something very, very specific. The delivered event is always going to be something very specific, but other events may evolve a little bit from time to time. So this is not to say that you only apply this when there is an absolute certainty that things do not change. It's understanding that things are stable enough, basically. So and it's also an understanding of when you have that language naturally, the terms being reused in different languages. So it's already there. I mean, if I can tell customer support and inform them that a shipment has gone into exception, and I can speak with
Sales.
If can speak with sales that the shipment has gone into exception, and I can speak with my integrations manager, and I mean, if I speak to different people with the same term and they understand it, it means that they can interpret it anyway. So the bounded context that they belong to, I guess, I would be, because bounded contexts are not only software, right?
Yeah.
So if they can interpret it, it means that this is naturally something that we can share. And as long as that happens, even though this may evolve through time, it's still something that is best reflected in software anyway. I mean, if the business understands the terms, and the terms are something that evolves as a whole, because if two departments use a term, and then one department starts using that term to mean something different, then the other people in that other department need to update their understanding. So reflecting this in software is actually good. Now, I don't know whether this is a heretical opinion or not, but it is something that definitely helped us quite a bit in the times that we have recognized it in our system internally, and it's certainly something that is in my opinion at least is in line with the domain-driven design principles.
Yeah, I guess so. I don't think it's theoretical, but there are other situations where people are using the same term for totally something different, and that needs to be recognized. But this is not the case for this. And to be honest, if you look at shipment, we're shipping stuff since people
Forever.
can travel.
Yes.
So that's a mature domain, and I know there are even some standards around logistics and stuff. So, and if I remember from my early days in logistics, ship truck loaded, truck unloaded, and so on. Those are part of standards. So there are published languages, so they are stable.
Yeah.
So it makes perfect sense.
Yeah. Well, I mean, it does make perfect sense, but there is a lot of so a lot of the, from my experience at least, and this may not be true, but this is what I've seen at least when speaking with some people, is there are a lot of articles out there that advise people against event sourcing, but in fact it's because people used event sourcing events for integration when they shouldn't have. So they didn't recognize that is not a shared thing, and so and they basically developed a system which breaks all the time, and they created essentially a very tight coupling to something that is very dynamic and evolving all the time, and that's obviously going to be causing pain. I mean, it's not something that you want to do. A public contract needs to be at least somewhat stable. You cannot like break your customers all the time, and all at the same time you cannot maintain a large amount of different versions simply as to not break your customers. So it has to be understood that there needs to be some understanding of the actual domain that you have, the volatility of what you have, and whether you are actually sharing terms in the language, or it's just the same word with different meaning. So it's important. So when I was speaking before, and I think thank you for mentioning it, it's important to recognize and only use only apply this pattern when the meaning itself is the same. So not just people recognizing a word, but understanding the same thing. Otherwise, it's a different term, and it's the why bounded context exists. So when I say shipment, if somebody understands something different, that's certainly not the same thing, and bounded contexts have conflicting interpretations, and that's exactly when you will need to not integrate. through the same events. You need to make some mapping to some what is public contract, and that public contract need to be documented and carry certain semantics.
Yep. Maybe to conclude, that's exactly what we said earlier. The
Yeah.
general advice is don't share your the events that you use for event sourcing, but there are cases where you can go outside because, for instance, you have stability in or it means the same to everybody in all parts of the either the software system or the human based system using the software.
Yeah, that is correct. It's basically when we're recognizing that this is like the same, it means the same thing. I think maybe that is another decision tree that needs to happen.
Cool. I can't wait to see it. You know, I love them, and you should publish them or write something about them. And I look forward to seeing it. Thank you a lot, Savvas. I hope we'll have another conversation soon. And thank you for your time.
Thank you, Yves. Thank you. No problem.
Bye.
Bye. Bye.